Hello there, welcome to CS School channel. In this video we are going to solve majority elements in array problem. I have added link to this problem in the description of this video, so do check it out and try to solve it on your own. If you can't solve it, come back to this video. So what's the problem? Well, the problem is shown on the screen. Given an array of size n, you need to return the majority element. Now what is the majority element? An element in the array which appears more than n by 2 times. So basically more than half the times. Okay. And another assumption which is given to us is that you may assume the majority elements always exist in the array. So there is no case where the majority element doesn't exist. So let's see some of the sample inputs and outputs for this problem. So we are given a first input as the array 3, 2, 3. The length of the array is 3, right? So divide 3 by 2, we get 1.5. We need to take floor of that division, which is 1, right? So we need to find an element which appears more than 1 time. Okay, so 3 appears 2 times, 2 appear only 1 time. So our output is 3, correct? Now taken another input. The array given is 2, 2, 1, 1, 1, 2. Okay, length of the array is 7. So divide 7 by 2, we get 3.5, and again we take the floor of that, which is 3. So we need to find all the elements which appear more than 3 times. So 2 appear 4 times, 1 appear 3 times, right? So our output is 2. So the first approach by which you can solve this problem is using brute force approach. So what we will do in the brute force approach is that we count all the occurrence of all the numbers. Okay, so what we will do, we will start with 2. We will count all the occurrences of 2. So currently there are 4 occurrences of 2. Then we will start with this 2. We will again count all the occurrences of 2. Here there are 3 occurrences. Okay, then we will start with 1. We will count all the occurrences and so on and so forth. Okay, and then we will find out the element which has more than n by 2 number of occurrences, and we will return that element as an answer. The time complexity of the solution is O of n square. Why O of n square? Because we will be using 2 for loop, one for iterating all the elements and second for counting the occurrence of each element, right? The space complexity becomes O of 1 because we are not using any extra space in this problem. The second approach by which we can solve this problem is using hash map. Okay, so in this approach we will create an hash map. So we will first iterate over all the elements in the array. So we will start with 2. We will create an entry in the hash map with key as 2 and value as 1. Okay, next time we will encounter 2. We will look up in the hash map whether 2 exists. If it exists, we will increment its count. Okay, then we will encounter 1. So we will create another entry in the hash map with value as 1. Then we will encounter 2 again. So we will increment this 1 from 2. Then we will encounter the third one. We will again increment the value of 1, so on and so forth. So finally the 2 has a value of 4 and 1 has a value of 3. Then we will go through all the elements in the hash map and find out the value which has more than n by 2 occurrences, which is 2 in this case. Hope you got the approach. Now what's the time and space complexity for this approach? Well, the time complexity becomes O of n. Why? Because we are iterating over the array only once, right? And what's the space complexity? Well, space complexity go till O of n again. Why? Because we are using this extra hash map, so it can store up to n amount of elements. So in the last solution, we have used O of n space. Let's try to eliminate that space using Moore's voting algorithm. Now it's really hard to come up with this algorithm on your own, so it's fine if you couldn't solve this problem on your own. Okay, this algorithm is based on the assumption that the majority element always exists in the array. If the assumption is not given to us, that means Moore's algorithm will fail in that case. Okay, so here is the Moore's algorithm. Basically we will take 2 variables, count and current element. Count will store the number of occurrence of a current element. Current element is nothing but a element that we are considering as our majority element. Then we will iterate over all the elements in the array. Initially the count is 0. In each of the iteration we will check if count is 0. If that's the case, then we will set our current element with the array of I, and then we will check if current element is equal to array of I. If that's the case, we will increment the count, otherwise we will decrease the count. So we will see the iteration of this algorithm step by step. After that I will tell why this algorithm works. Now let's see how does the Moore's voting algorithm works. Okay, here we are given an input array 2, 2, 1, 1, 2. Okay, initially I is equal to 0, count is 0 and current element is equal to -1. In the first iteration of for loop, I will be 0. Then we will go to this if condition. We will check if count is equal to 0. Well, that's the case. Currently the count is 0, right? So we will set current element is equal to array of I. Array of I is currently 2, right? So we will set current element is equal to 2. Then we'll go to this if condition. We will check if current element is equal to array of I, which is true. The same thing we have set in the previous if condition, and then we will increment count with 1. So count becomes 1, current element becomes 2. Okay, in the next iteration we will go to this 2. We will check if count is equal to 0. Well, that's not the case. Currently count's value is 1, right? Then we will go to this if condition. Current element is equal to array of I. Is this condition true? Yes, current element is 2, array of I is also 2. So we will increment the count. The count becomes 2, current element will stay as 2 only. Okay, in the next iteration we are considering this 1. Okay, so count is not 0, so this condition will not get executed. Current element is equal to array of I. Well, this condition will also fail because current element is 2, array of I is 1, right? So we will go to the else condition and we will decrement the count by 1. So count becomes 1 and current element will stay as it is. Okay, in the next iteration we will start considering this one. Is the count 0? No, that's not the case. Is the current element is equal to array of I? Well, the current element is still 2 and array of I is 1, right? Then again we will go in this else condition and we will decrement the count. So count becomes 2 and current element will stay as 2 only. Okay, in the next iteration we will start considering this one. We will check if count is equal to 0. Well, count is now 0, right? So current element will be set with value of array of I. Okay, so current element becomes 1 now. Okay, and we will go to this if condition. This if condition will result true. We will increment the count then. So count becomes 1 and current element becomes 1. Okay, then we will start considering this 2. Is count 0? No, that's not the case. Is current element is equal to array of I? Well, that's not the case either. Current element is 1, array of I is 2. Okay, so we will go to this else condition and we will decrement the count. So now count becomes 0, current element stays as 1 only. In the next iteration we will again check if count is 0. Well, the count is now 0, so we will set current element with array of I. Okay, so current element now becomes 2. Then we will go to this if condition. We will check whether the current element is equal to array of I. Well, that's the case. Then we will increment the count, so the count becomes 1. Okay, so in the last iteration of our for loop, the current element becomes 2 and count becomes 1. Then at the end we will just return the current element. Whatever the value of current element, we will return the calling function. In this case we will return 2, which is also our majority element. Now you must have a question like why this algorithm works. Well, this algorithm works because we always have a majority element. That means we have an element which is occurring more than n by 2 times, more than half of the times. So if we consider count as the variable which stores the occurrences of our majority element, count can never be negative for our majority element. There will be no point when our count becomes 0 for our majority element. Okay, as count never becomes a negative number, current element will always store our majority element. So now let's see the C++ implementation of this algorithm. So we need to complete this majority element function which takes vector of integers as an input and it expects an integer as an output. Okay, so we have initialized count with 0 and candidate with -1, which is our current element. Okay, so we have written a for loop which will iterate over all the elements in the array. We have first check if count is equal to 0. If that's the case, we have set candidate with numSci. Then we have checked if numSci is equal to candidate. If that's the case, we have incremented the count. Otherwise we have decremented the count. And at the end we have returned the candidate as per the algorithm. Now let's run this code. For running this code, I have written a main function. In the main function, we have created a nums array and we have passed that nums array to the majority element function. And whatever the majority element function returns, we have just printed it out on the screen. Okay, so let me just compile and run this code. So we get 2 as an output, which is also our majority element. So what's the time and space complexity of this algorithm? Well, we are just running one for loop over the input array, so the time complexity becomes O of n, right? And what's the space complexity? As we are not using any extra space, the space complexity becomes O of 1. So hope you understand the problem and its solution. We will be making more such videos in the future, so do follow us and subscribe to the channel. If you have any questions, do ask me in the comment section. I will be more than happy to help you. Hope to see you in future videos.